So like you said, my name is Ann Bertuccio. I'm on the Trust and Security Product team at Google Cloud, where I focus on container security. And what that really means is I think of my job as security education. And that fits well today because that's really the goal of my talk. There are two things that I want you to leave here with today. The first part of our talk is responding to vulnerabilities. And particularly, to respond to vulnerabilities properly, you have to understand what you're responsible for in the service that you're working with. And we're going to focus exactly on Kubernetes, because like you said, things get a little tricky when we're talking about who's responsible for what in the Kubernetes components. The second part of this talk is the getting better sleep portion. Your move to cloud native shouldn't keep you up at night worrying about incident management, vulnerability response. There are things you can do to improve your container security, and I'm going to give you a couple of those so you can worry less and sleep a little bit better. So for the next 40 minutes anyways, I want to have a common definition of cloud native. I know when you walked in today, you probably saw the CNCF's big signs and they said, this is the official cloud native definition. Cloud native is really typically, we're referring to anything that's microservices, and that might be containers, serverless, service meshes. I just want to focus on containers for the next 40 minutes. And also this being KubeCon, I'm going to make the assumption that you're either today actively using Kubernetes or you're considering using Kubernetes to manage and orchestrate those containers. And this talk will apply whether that's going to be straight from upstream, a distribution, or a managed service. And though I am from Google Cloud, this is a cloud agnostic talk. So there'll be one slide about a Google specific thing, but that'll be it. So to set the context of why this stuff even matters, like why am I here today talking about shared responsibility models, I want you to meet my fictional friends, Team Cat Attack. And Team Cat Attack is using a managed Kubernetes service through Captain Cloud, and they're using that to run a consumer retail app. So I want to take you back to December 3rd, 2018, and we're going to take a little peek at their internal team chat. Anyone else see this? It looks pretty bad. And then there's a tweet from Ian Coldwater talking about a Kubernetes CVE that was announced this day. And it reads, recently disclosed Kubernetes vulnerability allows all users, authenticated and unauthenticated, backdoor administrative access to the API server, including the kubelet, and it can't be easily detected in logs. So yeah, I would say that does look pretty bad, Purple Typist. You have that right. Ouch. Do we need to patch something? I'm not sure. Probably. Captain Cloud hasn't sent us anything, so maybe we're okay. Yeah, no news is good news, with a shrug emoji. I bet we're fine. So you don't have to raise your hands, but I heard some chuckles. So some of you have either probably seen this happen at a team you've been on. It might not be a far stretch to imagine it happening. The problem in this scenario is that was Team Cat Attack really fine? They assumed that Captain Cloud would have contacted them if they were affected or needed to take action, and it's entirely possible that they weren't affected, and they were fine, but the problem is that they're just not sure. They made a bunch of assumptions, and those assumptions are what you want to avoid, because that leaves you in a state of vulnerability when there potentially is actually a solution. One of the fantastic things about the cloud is that it lets us offload things to other people. We get to say, hey, here, you go take care of this machine. And that same concept applies from a security perspective. You're no longer responsible for hardening, attack monitoring, patch management for certain components. You only get to say, hey, here, you go protect this for certain things. The problem is, it's not always really clear what exactly those components are, and it varies by service provider and by the service that you're consuming. And these are where shared responsibility models come in. So a shared responsibility model is about delineating what a cloud services provider is responsible for protecting and what you as the user are responsible for protecting. I was curious how much people felt like they knew about shared responsibility models, particularly as they apply to Kubernetes. So I did some incredibly scientific research by putting a poll on my personal Twitter. And I asked, if I were to name a Kubernetes component, like the control plane, the Node OS, do you know where it falls in the shared responsibility model of your provider? Before I show you the results, there's a couple things to set the context, like any good scientist would do, about who my followers probably are. Someone who follows me on Twitter probably knows me from my work in some open source communities. They might be following me specifically for container security advice, or they really love my dog, whose name is Whitfield Diffie. If you're a cryptography nerd, he's the cryptographer. So with that, let's get to some of the results. 36% said yes, definitely, which, to be honest, amongst a subset of security people, I thought would have been a little bit higher. I mean, a high five to those 36%, but I thought it would have been higher. 14 said, I guessed, but I has docs. So they don't know the answer now, but they know where to go look, and that's really not a bad place to be. But 50% said, not really, which is just a very polite way of saying no, or they selected shared repeatsability, so they either don't know or were hungry. That's 50% of this group that doesn't know what they're responsible for in protecting the Kubernetes services that they are consuming. That's a pretty sizable portion, and as people are moving more and more things, particularly more sensitive and critical workloads to containers, half the group not knowing what they're responsible for is pretty critical. But I wanted to share this because if you're sitting there and you're feeling like, I'm Team Cat Attack, I'm Team Cat Attack, I don't know, I don't want you to feel alone. So to help you understand how shared responsibility models differ by services and service type, if you are that 50%, I'm going to walk you through a few examples. But I do have a disclaimer, and I'm sure my friends in legal are thrilled that I have this up. I'm going to use the word probably quite a bit, because I don't know what services and service providers you're using, and I can't speak to the specifics of what those are. So I'll say probably quite a bit. But I want you to leave this talk with the tools, knowing what to go ask your service provider. That's one of the goals today. So shared responsibility models are a little bit of a spectrum, and the pendulum is swinging between the provider and the user. The most responsibility the user has comes from our IaaS, infrastructure as a service, where that provider is really just responsible for the core infrastructure, and then the user is getting the responsibility for everything that they're choosing to put on top of that. On the other side, we have our software as a service models, and the user is just really responsible for the content and access to that content and managing it, and the provider is getting responsibility for everything that it takes to power that service. But what about our dear friend Kubernetes? The problem with Kubernetes is that it falls somewhere in the middle of this, particularly if you're using a distro or a managed service. One of the reasons we love distros and managed services is that it does abstract away some of those internals, the things you don't want to deal with, but you also still want to be able to configure Kubernetes for how you need it to work for your workload. And so that leaves you in a state where some components are user responsibility and some are provider. Specifically, how much of that is user versus provider is also going to differ by how you choose to consume Kubernetes. So just like that IaaS to SaaS pendulum swing, the more you're offloading to your provider, the less that you as the user are responsible for. And to give you a sense of what I'm talking about, on the farthest side, we have the team who has rolled their own of everything. You have your own machines, you might be running your own private cloud, you're pulling Kubernetes directly upstream, and you're running that. I'm terribly sorry, but you have no one to offload security responsibilities to. There's plenty of good reasons for doing this, but you don't get to share your security jobs with anyone. In the middle is a Kubernetes distro that you're running on a cloud service. So you receive this distribution of Kubernetes, and you'll probably receive patches from your provider, but you're responsible for the patch management of those components. On the far side, and this is, at KubeCon anyways, this tends to be one of our most common models that we see in this audience, are Kubernetes services. These are the managed services, and this is the one with the most questions, because it varies by the service provider. So what I want to do is look at some specific Kubernetes components and see if you're responsible for securing them. And that is really lesson number 1 of this talk. It is so important to know what you are responsible for. What you really want to avoid is that dangerous assumption state that Team Cat Attack found themselves in. So if you're here at KubeCon, this is probably pretty familiar to you. You've seen this. But what might be a little bit less familiar is the same slide from an attacker perspective. So if we start at the top, let's talk about why do I want to hack some of these components. One reason for hacking a container is to abuse compute. We really see that right now with cryptocurrency. Common thing, any sort of compute abuse, it might be cryptojacking. But I could also want to attempt to access customer data, workload data, schedule an arbitrary workload on that node. I might also want to get the container to try and get to the node so I can get compute resources again, and potentially do a denial of service on the master. That master is controlling your cluster. If an attacker gets your master, they basically have control of the environment, including the ability to take that environment offline. etcd is really what's keeping our cluster state. So if an attacker gets that, they can access, modify, or destroy your entire cluster, and potentially, depending on what's in etcd, they could recreate your application somewhere else. So if you hold that diagram in your mind, here are the 4 major components that I think you should make sure to find out, am I responsible for protecting this? The reason I'm calling out these components is that I think they're the ones where, depending on the context of the incident and your provider, there's probably the most gray area for you as a user. So let's start with Kubernetes itself. The gray area here is not necessarily who's responsible for what, but it's how do you get that information. So if you're consuming a managed service or distribution, and there's a vulnerability announced in that version of Kubernetes itself, chances are your provider is probably responsible for providing that patch, and you're responsible for upgrading to apply that patch. But the question is, where, when, and how does your provider communicate? If you think back to Team Cat Attack, like I said, they actually really could have been quite fine, but no one on that team said, hey, let me go check the security bulletin list. It looks like we're all right, everything's okay. You want to know where that information lives before you need it, so you're not frantically doing a Google search just because someone on your team saw something on Twitter. You also want to know about your provider's communication policies. So for example, in Google Kubernetes Engine, for our users, if there's something where they need to take action, that's when they get an email. If there's no user action required, they don't get an email, but it is listed in the security bulletins. So they always have a resource to go check, but that email acts as, it's kind of a flag that says, hey, we're only sending you this because you need to do something. If you're pulling directly from upstream and running in production, you want to make sure that you're signed up to receive Kubernetes security announcements. The other thing down at the bottom here is a little bit about Shadow IT. Shadow IT is kind of, those teams that spun things up on their own. They live sort of out of purview of what your operations team might be seeing, what your security team might be seeing, and that's really a permissions problem. But from a security perspective, those clusters that someone somewhere spun up still need to be patched and have vulnerability management applied to them. The control plane. That's the component that manages how Kubernetes communicates with the cluster and applies the desired state to the cluster. The control plane has quite a few different components, but the ones I want to focus on from a security viewpoint are that master VM, the API components, and etcd. From our charts before, when we talked about shifting to cloud, that lets you offload responsibility. And if you're on a managed Kubernetes service, you're probably not responsible for protecting that underlying machine that runs your clusters. However, that VM is running an OS. And depending on the context of the incident, the thing to note is that you might be responsible for applying OS and kernel patches. So we see this in things like the Spectre and Meltdown. That would be a situation where you were probably responsible for applying a patch that your provider gave you. Next, we have your API components. So those are your API server, the scheduler, the controllers. These are parts of the control plane, and they run on top of that master VM. So the question becomes, are you responsible? Is your provider responsible? Not too long ago, there was a vulnerability in the API, or the Kube API server, and its CVE number is up there. It's 2019-100-2100. And essentially, a really TLDR summary of this, the CVE, which is quite interesting. And I think, if I remember correctly, Ian Coldwater has a talk here this week specifically about this one, if I remember the schedule right. But it essentially let an authorized user create a denial of service attack on the API server. I would encourage you to use this as an example to go see how your provider handled communication about this particular CVE, what your team did, and what they should have done, and see if those match up. On that Kubernetes for Attackers slide, we pointed out that etcd is a pretty important component. Remember how compromised etcd could mean that an attacker could potentially recreate your application somewhere else. The good news here is that if you're using a managed service or a distro, you're probably not responsible for hardening and protecting etcd, and in fact, it might be abstracted so far away that you barely even touch it. But if you're rolling your own, you're definitely going to want to make sure that you check out etcd best security practices. CoreOS has some of these published, and make sure you're implementing them. Given the criticality of etcd, your security team might find it interesting to see what your provider has done to harden etcd, but there's really no action to take here. It's just an interesting thing. Could be fun to talk to your provider's security team about what they've done. So this bit, the Kubernetes dashboard, this is not as critical as some of those other components, but it's one with a little bit of an exploit history, so I wanted to make sure to talk about it. The Kubernetes dashboard is that beautiful web UI where you can deploy applications to your clusters, do some troubleshooting, see cluster health. But in the last year, you might have seen things like the Tesla hack, Aviva, or Weight Watchers. All those happened through the Kubernetes dashboard. And in these cases, what happened is that dashboard had exposed credentials, and it was also exposed to the internet. So attackers were pretty easily able to get to people's compute resources. In upstream Kubernetes, the dashboard is no longer deployed by default, and when it is deployed, it now has some fairly minimal RBAC configurations. If you're using a distro or a managed service, the thing to find out here is, one, is that dashboard deployed by default in the distro or the service that you use? And if it is, what are the default permissions on it? Are they using the standard RBAC configurations, or have they changed things up a little bit? The second part is that if your dashboard is not deployed by default, but you, the user, decide that you're going to go run it anyways, your team would like to use it, it is a beautiful little web UI, will your cloud provider notify you if there's a vulnerability in the dashboard? Or, since you added that on, is your team now responsible for monitoring Kubernetes dashboard vulnerabilities? These four are by no means an exhaustive list of the control plane components, but they were the ones that I specifically wanted to make sure you got called out today. So next up, the node and the Node OS. And this is kind of a big one, so I need a little bit of water here. All right. So if you remember from our diagram, a compromised node can potentially let an attacker attack the masters or abuse your compute resources. From a security point of view, there's quite a few components within the node that need to be protected. And for these components, you are probably not responsible for protecting them or patching them, but you probably do need to be the one who is applying and scheduling those patches to get the benefits. And there are a couple of corner cases, and that's what I really want to point out. So let's start with system containers. What I mean by system containers are the containers that your provider has added as part of their distro or managed service to do things like native monitoring, native logging. Those are your provider's added containers, so you are probably not responsible for them or doing attack monitoring on them or anything like that. But sidecar containers, and specifically in this context what I'm referring to are containers you've added on to run third-party tools. So a lot of runtime detection tools, how they're implemented is through a sidecar container. And it's totally fine, but now we have added a third party to our security communications and vulnerability management, our spectrum, our list. So now you have this third party that you need to make sure you go understand about their communications policies and how they do vulnerability management. Components like the kubelet, kubeproxy, your provider is responsible for protecting. But what about the container runtime? So let's say, for example, that your provider's default runtime is containerd, but you also have the option of using any OCI runtime. And you say, hey, let's change it up. I'm going to use Kata runtime, which is the runtime for Kata containers. So in this case, you've gone away from the default runtime. In that scenario, is your provider going to be giving you updates if there's vulnerability in Kata runtime? Do you need to now be monitoring it yourself? And finally, we have the node operating system. So remember that this is a separate OS from the VM OS that's running that master. And you probably have a choice of what this OS is. So for example, in GKE, we offer Ubuntu, but we also have container optimized OS, which is a minimal OS specific for containers. Your cloud provider or distribution is probably responsible for supplying you with patches. However, if you have zoned out for the last 22 minutes, I want you to just pay attention for the next 10 seconds. Your provider is probably giving you those Node OS patches, but you need to apply them to get the benefits. And you would be surprised how many people kind of see I saw it come in, I saw the communications, and I didn't apply to get that, I didn't upgrade to get that patch, I didn't apply it. Recently too, we've seen a lot of the recent Kubernetes vulnerabilities, that's where that's coming through, is that there are user-required, or user-applied patches are the solution there. So that's why I really wanted to highlight that one. My little asterisk here is because this is my one shameless plug for Google Kubernetes Engine. Because if there are any GK users in the room, I really want you to know about a feature we have called Node Auto Upgrade. So Node Auto Upgrade keeps your nodes up to date with the latest stable version of Kubernetes. So that means you're staying up to date with feature changes. However, for me as a security person, what it really means is that Google can apply a security patch to your nodes when it's critical. We can auto roll this out so you get it at the soonest point that we can in the vulnerability management process. So you can see a little bit more about Node Auto Upgrade in our GK docs, but if there are any GK users, I really wanted to make sure if there's one thing you do today, go turn this on. The last one to add to your "Am I responsible for this" list are projects that are used in the default configuration of your distribution, and then projects that you have chosen to add on yourself. So projects that come as part of the default configuration. These would be things like if your provider uses Calico for networking, for example, which is a very common one. That provider should be on that community's security distribution list. But if I was shopping for a Kubernetes service today, it would be one of the things that I would just ask about. Just make sure, are you, all the open source projects that are part of this configuration, are you actively involved in the security distribution list? It's sort of like shopping for a car with seatbelts. You would be surprised if someone said, no, this car doesn't come with seatbelts. You wouldn't want to buy it, but you probably want to peek in the window and make sure there are seatbelts there. That same responsibility, though, applies to you if you choose to run an open source project outside of that supported configuration. So for example, someone on your team finds project X, they're like, this is really neat, it does Y, it's going to solve our problems, fantastic, let's roll it out. You now need to be subscribed to wherever that community does vulnerability disclosure and security announcements. In a recent open source security survey, almost 30% of respondents said that if there was a vulnerability in one of the open source projects they consume, they don't know how they would find out about a security announcement. That's a pretty sizable chunk of people that are running things who have no way of getting information. Which brings me to a point for people who are new to open source. Is anyone here kind of newer to consuming an open source project, or this is maybe, all right, maybe you're shy, or maybe you're just you've been on like the Linux distribution channels forever. If your team is using a new tool and it is not super obvious where the community is doing this disclosure, just go find a maintainer and ask. I know just ask sounds very obvious, but as someone who's been on the other side on vulnerability management teams, we really, really want you to have this information. So I would so rather get an email from someone, get a Twitter DM that's like, hey, where's the security announcement list for this project, than have a user running it, particularly running it in production and going without this information. Okay, so workloads. This is the fun stuff. And this is the stuff where there are the preventative measures that you can take, so you don't feel like for the last 25 minutes, this lady in a wild dress stood on the stage and just gave you a list of questions with no answers. If you remember from our IaaS and SaaS charts, the workloads that you're choosing to run are yours to protect. For Kubernetes, that includes the workloads themselves and the configurations that you have made that pertain to those workloads. There's a lot you can do to protect your workloads in Kubernetes. There's so much so that this slide is probably rather overwhelming. So rather than walk through all of these, I've highlighted 4, and I'm going to give you a bonus 5th one. And this is the starting place. So if you do these 4, I think you're going to breathe a little easier, sleep a little better, and then you can continue to check all of these off on your workload security journey. Number 1, keep Kubernetes updated. That was the patching that we've just been talking about. If you've never been a red teamer, I want you to put on your attacker hat for just a second. Think about this. You have a goal. You want something. You probably want to get some resources or workload access. If that's my goal, why would I spend time doing the complex thing, doing the challenging thing? It might be fun and intellectually stimulating, but that's not my goal. My goal is to just get resources. So I'm going to do the easy thing. The easy thing is an unpatched known vulnerability. That's something where I know the exploit, I understand what it is, I know how I'm going to exploit it, and someone hasn't patched for it. That is the easy thing. We can say it's the low-hanging fruit, and I would like to say it is so low that it is on the ground, perfectly ripe, wrapped in a little bow. So, number 1, patch, 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 keep Kubernetes updated. Number 2, using trusted, verified container images. This first part, is about defining trust for your organization. So everyone has a different security profile here in this room, and it's up to you to think about and decide, what do I trust? Common things that you might think about in this definition are the origin of the container image, if your QA team has approved and signed that image, if the image has been modified from build to deploy time, so that's verifying that it hasn't been tampered with, and that image is what you say it is when you go to deploy it. The other part of this, and we heard this morning a little bit about building things into your CI/CD process, is the same way that, I'd like to think if tests fail, we don't deploy things. If your definition of trust fails, you can gate on trust as well. So you can say, this image doesn't meet my requirements for what I want to have in my environment, don't deploy it. The good news is, if you are a GK user, we have this available to you in a product called Binary Authorization. If you are not, there's an open source version of it called Kritis that you can go and take a look at. Number 3, scanning for known vulnerabilities in your container images. So same idea as we were talking about patching, what you're responsible for Kubernetes. Patching your container images is critical to making sure that you're not vulnerable to that known exploit that has an easy remediation. You should be scanning when an image is added to your registry, and you should also be triggering a scan whenever that vulnerability database receives an update. Scanning is probably something you're going to want to have as that basic definition of what do I trust. Scanning alone, though, is not sufficient. You should be scanning and then identifying if a fix is available and applying that fix before the image is deployed. It's not enough to just say, I know there's a vulnerability in it, but push it anyways. Just keep going. That kind of defeats the last 30 minutes of what we've been talking about. Number 4 is to consider sandboxing. So depending on your security profile and what your application is, you might want a second layer of isolation between your container workloads and that shared host. Particularly if you're running untrusted workloads, you're running the code of a third party, you're doing SaaS services, you're going to want to be applying a defense in depth philosophy to your containers and looking at all those isolation solutions. We have a couple of options in the open source world for container isolation. You can look at gvisor, which uses a user space kernel to intercept and handle syscalls. So you're reducing the interaction directly with the host and reducing that attack surface. You can also look at Kata containers, which is taking a different approach to isolation and putting a lightweight VM around each individual container. If you're a GK user, you will now see enable GK Sandbox in your Cloud Console, and that's gvisor. Number 5 is to have an incident response plan before you need an incident response plan. Incident response needs a couple of things to be successful. One is monitoring and alerting. You need to know that something has happened so you can take action on it. The other part is a runbook with a detailed description of what do we do next, and particularly assigned roles of who does what. If you've ever taken emergency management training or emergency response training, you'll go through this step where they say, there's an emergency, you need to point at someone, call them out, and tell them, you go call the emergency line. What that's about is that, if someone is not directly told, I need you to take action, you are the person responsible for this, everyone just stands around going, oh my goodness, there's an emergency, and then that next step never happens. So that's the really important part of your runbook, having assigned roles. Another thing that you might want to look into is templating your communications as much as you can beforehand, and knowing who's in your sign-off chain for incident communications. Particularly if you're customer-facing, this is something where your legal team will probably be involved, your security team will probably be involved, but knowing who's in that sign-off chain and having as much as you can written out before you need it is really helpful to making things go smoother. So, I want to walk you through, whoops, yes, there we go. Oh, no, we're back to, what's going on here? Well, these are our 5. Let's see. Excellent, okay. So I want to apply these 5 if Team Cat Attack had them. Here we go, all right. Anyone else see this? It looks bad. And here we have our CV, and again, that, remember, it did look quite bad. Ouch. I'll go check the Captain Cloud security bulletins. Excellent, great answer. It looks like Captain Cloud wrote out a patch that was automatically applied. Big bold text, no user action is required. Team Cat Attack now knows they're not making assumptions, they have a definitive answer. Thanks for confirming. They didn't send us anything, which is what they would do when we need to take action. Someone knows the policy and they know the answer. Woo, Team Cat Attack is good to go. So that was much better than before, right? Much better. So we have gone through quite a bit in the last 35 minutes, and I've given you quite a bit of homework. But this is your one slide. If you remember nothing, this is your takeaway slide. Cloud Native is fantastic for abstracting things away, but what it leaves are a lot of questions about who's responsible for what and how you respond to that. So part one, know what you're responsible for. You want to make sure you're pulling up your provider's docs about the Kubernetes distro, the control plane and its components, the node and the node OS, and any projects that you have added on. You also want to make sure that you know how your provider communicates, where they communicate, and when they communicate with you. To help you sleep at night, there are 5 things that you can do to harden your containers. Keep Kubernetes up to date, that's patching, patching, patching. Use trusted, verified container images and scan them for known CVEs and remediate where you can. Think about sandboxing and look into the open source projects that address this. And then make sure you know your incident response process before you need to use your incident response process. So with that, I wish for you to go get some better sleep. Thank you very much.
Questions? Questions? Anyone? Got a few minutes. I see some hands back there, Michael. Hold on, we'll bring you the mic. It's easier.
Regarding sandboxing, I'm not sure that I got the idea and how it's not counterintuitive to Kubernetes, elasticity. Maybe I missed the concept. Can you elaborate on that?
Can you elaborate on sandboxing and how it's different to what the container runtime does traditionally with C groups and namespaces, and why you would want to have that additional layer?
Yes, absolutely. Gosh, I wish I had an architecture diagram. So if you look at how containers are traditionally deployed, you have a shared kernel between them. And that's part of kind of that density and thinking about how are we going to deploy our applications in a more dense way. They have that shared kernel. The problem is from security person hat on, if there is a container breakout, I now have access to that host kernel. And from that host kernel, I can potentially get into the workloads in that other container. So that's a pretty risky compromise that you're looking at. Now, I will say container breakouts are not something that we've really seen in the wild too much. We have seen security researchers, they've proven that. There's been some recent vulnerabilities, like the runC vulnerability that happened in February, I believe it was. So it's proven, but it's really, to be honest, I think the thing that should be keeping you up at night, I know this was about sleep, keeping you up at night are those basics. Because like I said, an attacker, if I can do the easy thing, why would I do the hard thing? However, sandboxing is about thinking about if I have a sensitive workload, an important workload, I want a minimum of 2 layers of isolation. I don't just want to rely on my namespaces and C groups as my boundary. If someone were to get privilege escalations beyond those, I want to make sure they hit another layer. And so in gvisor, for example, that's that user space kernel. In Kata containers, that's using the hypervisor as that second layer. So sandboxing, there are some performance hits that you'll take on these methods, but it's really for looking at what sort of performance hit am I willing to take for the increased security depending on what you're running.
Does that answer your question?
Anyone else? No? All right. Thank you, Anne.
Thank you very much.